At least in the way we see them from Earth. When we think of stars, we probably picture tiny, shiny objects in the night sky. However, stars are not the same thing. Betelgeuse, one of the largest stars, is significantly larger than our sun. Scientists have been baffled by this star for years, but recently, something more troubling has been occurring with Betelgeuse, causing scientists and other knowledgeable individuals to be extremely concerned. In this video, we'll talk about the worrying news about Betelgeuse, how the James Webb Space Telescope predicted it would be destroyed, and how this new development will affect our galaxy and our lives on Earth. Cosmologists have long been fascinated by the enormous star known as Betelgeuse, which is a cosmic wonder. Ptolemy, a Greek astronomer, was the first to find it. This enormous star can be seen in the night sky from Earth, especially in the wintertime. This star is probably something you've seen or heard of if you like constellations. The reddish-orange star that identifies the Orion constellation's upper left shoulder is this one. This ancient star is one of the brightest stars currently visible in the night sky. Betelgeuse's brightness, on the other hand, fluctuates rather than remains constant. This star has many unique characteristics, but this fluctuation is just one of them. In reality, most of the stars in the night sky are far away from Earth. Earth is 4.2 light-years away from the nearest star. Consider traveling at the speed of light for an entire year if you don't understand how the distance measurement of light-years works. It has been demonstrated that light can travel 186,000 miles per second. As a result, 1 light-year is the amount of time that light can travel. You'll have billions of miles if you do the math. Therefore, when we say that the nearest star is 4.2 light-years away, we are referring to a distance of billions of miles from Earth. But you know what? Betelgeuse is one of those stars that can be seen even further out. Since Betelgeuse is about 600 light-years away from Earth, it would still take 600 years to get there at the speed of light. Even our fastest spacecraft cannot move at that speed, but this star can still shine so brightly in our sky. Betelgeuse's size and brightness, among other characteristics, are the reason why, despite its distance, it is so bright. Betelgeuse is approximately 500 times as big as our Sun. It is thought to have a radius about 1,000 times larger than the Sun. With sophisticated telescopes, it appears as a disk in space, whereas other stars appear as tiny points of light because of its size. It is speculated that the reactions taking place in the atmosphere's outermost layers are the cause of this appearance. Betelgeuse has a mass of between 12 and 19 solar masses. Astronomers typically measure mass in solar masses. 2 times 10 to 30 kilograms is the equivalent of 1 solar mass. Since there are no other planetary bodies orbiting around Betelgeuse to compare with, scientists are unable to determine its precise mass. Additionally, we are unable to directly measure it from Earth. However, it has been demonstrated that this star is at least 12 times as heavy as our Sun. The magnitude of Betelgeuse's brightness ranges from 0 to plus 1.6. Betelgeuse, to use a more familiar expression, is 16,000 times brighter than our Sun. It was no wonder it was dubbed a red giant. However, Betelgeuse's brightness varies rather than remains constant. Its pulsations are the cause of this fluctuation. To put it another way, Betelgeuse changes shape. It dims when it contracts, but when it expands, it becomes brighter. This procedure can take anywhere from 10 to 100 days or even longer. Betelgeuse's surface is covered in dark magnetic spots, making it unique. The downside of these strong magnetic spots is that they prevent hot gas from reaching the star's outer surface, which makes the star cooler in these areas. Despite the fact that the magnetic field in these areas is much stronger than it is at the normal surface, Betelgeuse is cooler than our Sun despite its size and brightness because it has more of these spots than our Sun. Betelgeuse's dark magnetic spots are much larger and more numerous than those on the Sun. To give you an idea, Betelgeuse's spots may be twice as big as Earth. Additionally, Betelgeuse's magnetic field is 1,000 times stronger than the Sun's. The gases on the surface of Betelgeuse appear to be arranged in arcs or loops when observed through a telescope because of this field. The surface temperature of Betelgeuse is approximately 3,500 Kelvin. The star's dim red color and low energy output are a result of this low temperature. Even though Betelgeuse is a red star now, it wasn't always that way. Similar to our Sun, it was yellowish about 2 million years ago. The color started to turn orange-red over time, and about 2,000 years ago, it started slowly turning into the red star we know today. Because of this, scientists believe that the star is getting older. As much as 7,500 times more energy is released by Betelgeuse than by the Sun. If it hadn't been so far away and in its prime, it would have been a fierce rival to the Sun on Earth. It is quite remarkable that Betelgeuse, 600 light-years away, can still be seen and identified by the naked eye at night. Our Sun is so powerful because it is only 8.3 light-minutes away from Earth. We would also be able to see Betelgeuse during the day if it were just a little bit closer. However, due to its enormous size, if it were to take the place of the Sun, it would engulf or move the Earth and the 4 planets that are close to it. Furthermore, it produces more radiation than our Sun, even if it could match it. Betelgeuse, also known as Betelgeuse, is a supergiant star 600 light-years from Earth in the constellation Orion. One of its most striking features is its enormous size. If it were located at the center of our solar system, it would easily cover Jupiter's orbit because its radius is approximately 500 times greater than that of our Sun. Betelgeuse, in contrast to the majority of other stars, can be observed through powerful telescopes as a distinct disk rather than a point of light because of its enormous size. Betelgeuse is not the most massive star, despite its immense size. It has a mass that is between 12 and 19 times that of our Sun. The difficulty in accurately measuring the mass of stars without a companion star or other objects to serve as gravitational reference points is the cause of this variation in mass estimation. Nonetheless, Betelgeuse continues to be a significant stellar entity despite its lower estimated mass. Another notable quality of Betelgeuse is its brightness. Its brightness fluctuates irregularly over time, ranging from magnitude 0 to plus 1.6. A magnitude 0 star is approximately 2.5 times brighter than a magnitude plus 1 star for comparison. Betelgeuse can shine up to 16,000 times brighter than the Sun. The star's pulsations, which are periodic expansions and contractions brought on by internal processes, are responsible for this variability. Betelgeuse becomes brighter when it expands, while it dims when it contracts. These pulsations, which contribute to its dynamic appearance in the night sky, can last for days or even months. The surface temperature of Betelgeuse, which is about 3,500 Kelvin, is quite low for such a large star. As is typical of red giant stars that are nearing the end of their life cycles, this gives it a distinct reddish-orange hue. Betelgeuse, like other red giants, is in the final stages of its evolution. At this point, it has run out of hydrogen fuel in its core and started fusing heavier elements together. The star expands outward and generates energy through this fusion process. Complex physical phenomena abound in the star's atmosphere. On its surface, it has dark magnetic spots that are much larger and more numerous than those on our Sun. These hot spots on the surface of the star are caused by intense magnetic activity that prevents hot gases from flowing to the surface from deeper within the star. Betelgeuse is also a prominent celestial object due to its history and cultural significance. Betelgeuse has been observed and documented by various civilizations throughout history. It has been known since ancient times. Because it can be seen in the night sky, especially during the winter in the northern hemisphere, it has been a prominent part of mythology and constellations. Due to its dimming episodes, which began around the end of 2019 and continued into the beginning of 2021, Betelgeuse has received a greater amount of scientific attention in recent years. The star's brightness fell to levels never before seen during these times, leading astronomers to speculate about its future. Betelgeuse, more commonly referred to as Betelgeuse, is a prominent star in the Orion constellation, about 600 light-years from Earth. It stands out not only because it is one of the brightest stars in the night sky, but also because of how big it is and how different it is from one another. Astronomers and skywatchers alike have been captivated by this supergiant star for centuries because it provides insights into stellar evolution, cosmic distances, and the universe's dynamic nature. The fact that Betelgeuse is a red supergiant star indicates that it is currently in the latter stages of its stellar evolution. Regards to size, it's truly enormous. Betelgeuse would engulf the inner planets if it were located at the center of our solar system. It would extend beyond Jupiter's orbit. Betelgeuse is one of our galaxy's most studied and intriguing stars because of its enormous size and varying brightness. Astronomers have long been intrigued by and interested in the star's significant brightness variation. Betelgeuse has been observed to dim and shine irregularly, ranging in magnitude from 0 to plus 1.6. Betelgeuse can reach a brightness level that is 16,000 times brighter than our Sun at its highest point. Pulsations, which are periodic expansions and contractions in the outer layers of the star, are the cause of the brightness changes. Betelgeuse changes color when it expands and dims when it contracts. These pulsations may last for days, weeks, or even much longer. The reddish-orange hue of Betelgeuse is due to its relatively cool surface temperature of about 3,500 Kelvin. This color is typical of red supergiants, which are fusing heavier elements after exhausting the hydrogen fuel in their cores. It is anticipated that Betelgeuse will eventually die in a spectacular supernova explosion as this process continues. The atmosphere of the star is dynamic and complex. On its surface, Betelgeuse has large, dark magnetic spots that look like sunspots but are much larger and more numerous. The intense magnetic activity in these spots prevents hot gas from reaching the star's surface, resulting in the formation of cooler, darker regions. The star's behavior remains a mystery because of these magnetic spots, which play a significant role in its variability. Betelgeuse is one of the most well-known stars in the night sky because it is in the Orion constellation. It has been a fixture of human observation for thousands of years and represents the giant hunter Orion's shoulder. From the Greeks to the Egyptians, Betelgeuse has a long and storied history in astronomy thanks to its inclusion in their star charts and mythologies. Betelgeuse experienced a dramatic and unusual dimming toward the end of 2019 that sparked widespread speculation that the star may be approaching its death and may soon explode as a supernova. Betelgeuse's brightness decreased to its lowest point in recorded history as a result of this occurrence, which is referred to as the Great Dimming. Although the dimming eventually subsided, it rekindled interest in the star and sparked a flurry of investigation into its cause. At first, it was thought that the dimming of Betelgeuse was a sign of a supernova explosion, which would be an extraordinary event that could be seen even in daylight from Earth. However, additional observations suggested that the dimming was probably caused by a combination of factors, such as changes in the activity of the star's surface and the ejection of material that resulted in the formation of a dust cloud that temporarily obscured the star's light. Astronomers continue to pay close attention to and research the Betelgeuse galaxy. Although it is still unknown what will happen to it in the end, if and when it goes supernova, it will shed light on the dynamics of supernova explosions and the life cycle of massive stars. Betelgeuse continues to shine brightly in the night sky as a sign of the universe's vastness and complexity, as well as its ever-evolving character. It is unlikely that Betelgeuse will explode in our lifetime. Its inevitable explosion may still be tens of thousands of years away. Though, the supernova, if and when it occurs, will be a spectacular event that may leave behind a neutron star or black hole and will outshine the full moon for weeks or even months. Betelgeuse will continue to be a fascinating study object and a representation of the dynamic and changing universe we inhabit until then.